This is the Algebra 1 Summer School Unit 6 Lesson 3 Notes video. We're going to talk about the vertex form of a quadratic today. So what we have in this first example is a picture of a parabola, which is a quadratic function. It says the equation of the quadratic function below is f of x equals the quantity x minus 2 squared minus 4. We're going to fill in the details of this graph based on the picture they give us. The vertex of this equation appears to be at 2, -4. Now remember, the equation of the axis of symmetry is the line that cuts right through the middle of the parabola. That's always a vertical line, which is x equals, and it equals the x value of the vertex. Notice that those are the same. This vertex is a minimum. It's the lowest point that this graph has. The y-intercept is where we cross the y-axis. That appears to happen at the point 0, 0. Then we have to find the x-intercepts where I cross the x-axis. Well, this appears to happen twice, and that happens at the point 0, 0 again. It's pulling double duty there, and the point 4, 0. Now on my graph, to find the domain is the set of x values. Those go from left to right. So when I look to the left of my graph, it has an arrow, which means it's going to go on forever to the left and on forever to the right. So we say that the domain of a parabola is all real numbers. It's going from -infinity to +infinity. Now the range of my graph is the set of y values. So this range always includes a y. My y values that are starting at the lowest point here, so -4, and it looks like all the rest of the y values are greater than or equal to -4. So that's the range, the set of y values. Now there's a question down below here with an asterisk. It says, do you see a relationship between any of the details of the graph and the equation you were given? Well, let's notice one thing here. Let's look at the vertex. And let's look at the vertex form. Notice that the equation of the parabola has a 2, so does the vertex, and a -4. That's going to come in handy. That's what we call vertex form of a parabola, which we're going to talk a little bit more in detail about on the back of your notes. Now for example 2, let's look a little bit more. Let's make a few more connections, and then we'll get to vertex form. It says, look at the following 3 graphs of quadratic functions. Identify the solutions or zeros of each vertex and their function. Of each vertex and the vertex of each function. So we need to first find the vertex for this first graph. This appears to be at 1, -4. And the solutions of this first graph look to be at -3 and +1. Now when I look at the vertex of the next graph, I have a vertex that it looks like -1, -8 this time. And the solutions here are also at -3 and 1. All right, let's look at our third graph. The vertex appears to be at -1, -2. And for the third time, the solutions are at -3 and +1. Well, what was the same for each function? It looks like the vertex was exactly the same for each function. What was different? Well, I'm sorry. The vertex was exactly different. The x-intercepts were the same. I must be getting tired here. So the x-intercepts were the same for each function. The vertex was different for each function. All right, it says, what's causing the difference? Well, it looks like the graph has a different steepness. All right, there's a different height of the graph, how tall or short it is. All of this is tying together. We're looking at the vertex. Right? The vertex changes of these parabolas. So we had standard form of a graph. The quadratic, it says, written in standard form, is known as ax squared plus bx plus c. That's the kind of quadratic that we're used to factoring and the kind that we spent last lesson graphing. A quadratic function, part 2, can also be written in this format. Now that looks a little bit goofy. That is called the vertex form of a quadratic. It gives us a lot of good information about quadratic functions. It says the turning point, or the vertex, this is the key, this is the most important one, of the vertex is at negative h, comma, k. Now you might be thinking, oh my goodness, I don't know what negative hk means. Once we put numbers with it, it'll make a lot of sense for you. The axis of symmetry, that line that divides the graph in half, remember we said is always an x equals equation, and it's always equal to the x value of the vertex. So here x is negative h. And just like in standard form, if a is greater than 0, that means it's positive, the graph is going to open up. When my graph opens up, my vertex is a minimum. If a is less than 0, meaning if a is negative, the graph opens down. So the turning point when you open down is a maximum. Okay. Let's put some numbers to vertex form so it seems to make a little bit more sense. Since each of the quadratic belows are written in vertex form, identify the vertex, decide if it would be a maximum or a minimum, and state the equation of the axis of symmetry. Here's how the turning point works. The equation up above said the turning point was negative hk. Well, that negative means the opposite. So what you do is you take the opposite of the number in the parentheses. So the opposite of 3 is negative 3. And then the exact same number for the y value as the constant outside. So your turning point is at negative 3, negative 4. That's the vertex. This would be, well, let's see, we have a positive. There's no negative in front, so my graph is going to open up, which tells me I'm going to have a minimum. And my axis of symmetry is always equal to the x value of the turning point. If you struggle to see that, go ahead and graph it on your calculator. When I graph this function, x plus 3 squared minus 4, when I graph it, you should be able to see that I have a minimum, and it also appears that your vertex is at negative 1, 2, 3, negative 4. All right, so let's go back to the next one. The turning point of the next equation. Again, I take the opposite of what's in the parentheses, so that's positive 7, and then the same number that's outside, negative 1. Because there's no minus sign out in front, my graph opens up, so I have a minimum, and the axis of symmetry is x equals 7. Last problem on this part. The turning point, I'm going to look at just the numbers in the parentheses and outside the parentheses. The turning point is the opposite of negative 5, so positive 5, positive 6. Notice that this time there's a negative in front of the whole equation, so your graph opens down, which says this vertex is a maximum with an axis of symmetry at x equals 5. All right, vertex form is just one of those things you need to practice a little bit with, but once you get it, you're really going to get it for good. All right, last two problems here. Is that we're given a parabola, and now it says write the equation of the parabola below in vertex form. So first of all, I'm going to identify the vertex. It's already labeled for you at 3, 6. Then it asks, is my graph opening up or down? Well, it's opening down. The reason we need to know if it's opening down is because we're going to be writing the equation. And when my parabola is opening down, my equation starts with a negative. Now, all vertex form always has parentheses with an x inside and a squared outside. The number that goes in the parentheses with the x is the x-coordinate of the vertex. But it has to be the opposite sign. So it's going to be x minus 3. And then the number outside is the y-coordinate of the vertex. So the equation of this parabola is negative x minus 3 squared plus 6. All right, Finally, this is an OST, Ohio State test question. It says a function is shown below. 5 times x minus 2 the quantity squared plus 3. It says what's the minimum value of the function? Well, this is just asking me what's the vertex of this function. And if you understand vertex form, you should be able to get this with no problem. The vertex here is the opposite of the number inside the parentheses, which will be 2, and then the positive 3. That is your minimum value. We know it's going to be a minimum because the number out in front of the parentheses is positive. So my graph is opening up, which makes that vertex a minimum. Go ahead and try the practice that goes for vertex form, and then there's going to be a mixed practice following it. It has good practice of solving quadratics in vertex form that you might need.